says how far did the object travel in the interval 1 to 2 seconds. So if we look here, in the interval, whoops, from 1 to 2 seconds, we can basically just look at the graph and say from 1 to 2 it moved 4 meters. Now it says the displacement from 0 to 5 seconds. There's two ways we can do this. One is, let's use the displacement graph. So here, I notice that I go from 0 at 0, and then at 5 seconds, I'm at 5 seconds again, so that would be 5 meters using x final minus x initial. But what we were also told is that if we get the area under the velocity graph, let's do that just to check. So we know that we go from 0 to 2, 2 to 4. So our area is going to be 2 times 4 plus, and then we have this negative area here, and that's going to be 1 times negative 3. And that also gives us 5 meters. Again, I'm looking at this positive area here that's 8, and this negative area here, which is negative 3. And I add that up, and I get 5 total. Or I can say, look, I'm at, if I look at this 2, 4, 6, 8, I'm at 5 right here, starting from 0. It says find the average velocity from 0 to 5 seconds. That's going to be the displacement over the time, and that's going to be 5 meters over 5 seconds, which is going to be 1 meter per second. And what we mean by explain is just show the work. Now the average speed is going to be the distance over the time. Well, the total distance is going to be 8 plus 3 divided by this time of 5, which is going to be 11 over 5, which is going to actually give us 2.2 meters per second, gauging by the total distance, where I'm going 8 forward and 3 back for a total of 11. And that's giving me my average speed. Lastly, I have a race car traveling, and let's just write its equation down. 95t plus 450, and we want to know where it's going to be in the next, after 12.5 seconds goes by. Sorry, that's just plain old x. So that's going to give us the equation x equals 95 times 12.5 plus 450. And so when we total it, let's actually just work it out. 95 times 12.5 plus 450. 95 times 5 plus 450 gives us 1,638 meters. So that is the last page of the homework, and I will upload these solutions now.